In this video, we're going to be looking at the discriminant. Now, if you square any real number, the result is going to be greater than or equal to 0. So for example, 2 squared is equal to 4. 0 squared is equal to 0. And negative 2 squared is equal to 4. So whatever we do, it's always going to be greater than or equal to 0. So let's look at the quadratic formula and explain it using that. So if you haven't seen my video about the quadratic formula, I'd recommend you check that one out because it will help you to understand what I'm about to explain. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so if we have the formula ax squared plus bx plus c, then we can just plug in each of those numbers into our expression and that will give us the value of x. So if the value that comes out underneath our square root is negative, x cannot be a real number and there will be no real solutions. If the value under the square root is equal to 0, both solutions to x, because usually when we have a quadratic expression we're going to get two solutions of x, both of those solutions will be the same. So b squared minus 4ac in this example here, this is known as the discriminant. Okay, discriminant. Obviously we don't actually have to write it all out like this to get our discriminant. We can just say b squared minus 4 times a times c, and that is our discriminant. Okay, so let's focus in on the discriminant. So let's rewrite this discriminant now. B squared minus 4ac. So the value of the discriminant will therefore show how many roots our function of x has. So if b squared minus 4ac, okay, is greater than 0, so if this value is greater than 0, then that's going to have two distinct roots. There are going to be two answers of x. If our discriminant is equal to 0, we're going to have one repeated root. So we're going to have x is going to equal to 3, x is equal to 3, x is equal to 2, x is equal to 2, and so on. So it's going to have one repeated root. And then if it is less than 0, then we're going to have no real roots. There's going to be no answers at all. Okay, there's going to be no values of x. And you can use the discriminant to check the shape of the sketch graph. So let's say we were to sketch each of these particular things. So we got our discriminant, b squared minus 4ac, and let's say we took an example where it is above 0, so when the discriminant is greater than 0. If we have a graph that looks a little bit like this, then we know there's going to be two distinct roots, which means it's going to cross our x-axis at two distinct points. And so therefore, it's going to look a little bit like that. That should be crossed over there. Okay. If there is just the alternative is as well, obviously it could also be two distinct roots, but the other way around as well. So it crosses over whether it's like a U shape or sad face, and obviously that depends on the coefficient of ax squared. So it depends on that. So if we've got ax squared plus bx plus c, if that is positive, then it's going to be like a U shape. If that is negative, it's going to be like a sad face. If we've got a repeated root, so let's say we've got b squared minus 4ac is equal to 0, and we sketch this on a graph, then it's just going to have one repeated root. So that means it's going to only just touch the x-axis at one point. And so if this is positive, we're going to get a graph that looks a little bit like that. And if it's a negative ax squared, we're going to get a graph that looks a little bit like that. And then finally, what happens if our discriminant, b squared minus 4ac, is less than 0? Well, our graph is going to look a little bit like this. Let's draw our axes. and it's just not going to touch the x-axis at all. It's not going to have any roots. So it's either going to be something like this or something like this. You know, it's just not actually interacting with the x-axis line at all. So let's look at a question to explore the concept of the discriminant a little bit more. Okay, x squared plus 6x plus k equals 0. So let's find the values of k for which x squared plus 6x plus k equals 0 has two real solutions. Now, first of all, let's identify what a, b, and c are. Okay, so a is equal to 1 because it's just 1x squared, b is equal to 6 because it's 6x, and c is equal to k, as that is our last thing over here on the right hand side. So what we want to do is to determine what this means. Well, if we have two real solutions, that must mean that our discriminant b squared minus 4ac is greater than 0, because that will give us two solutions. Okay. So what we want to do then is to plug in these numbers into our discriminant so that we can work out the value of k. So, or the range of values for k for which we will get two solutions. So obviously b squared is 6, so we're going to have 6 squared minus 4 times 1 times k, which is greater than 0. And we can simplify that as 6 squared is equal to 36, minus 4 times 1 times k is 4k, so that gives us negative 4k, and that's got to be greater than 0. And obviously we can then move the 4k to the right hand side to give 36 is greater than 4k. And then if we just divide both sides by 4, so we can divide this by 4 and this by 4, that's going to leave us with 9 is greater than k. So k is going to be less than 9. And that's going to give us the values for which x squared plus 6x plus k is going to have two real solutions.